what we've talked about before in class is that when we've been talking about Bohr models, we've stopped at element 20. And we've said that like with element 20, which is calcium, try to draw that, past that we get into transition metals, and things get a little more complicated because when we hit transition metals, they are what we call inner electrons, where they go back a shell and they fill up. So we have not learned what's called electron configuration yet, which again would make a little bit more sense, but we just don't have time to go into that this unit. What we have talked about so far leading up with Bohr models is that the first shell can only hold 2 valence electrons. Let me extend this out. So valence electrons, and then every other shell past that can hold 8 valence electrons. And that is still true. Every shell past the first shell can hold up to a maximum of 8 valence electrons. However, when it comes to actual electrons, some of these shells can hold a lot more. So what we actually end up seeing is that the third and fourth shell, for instance, can actually hold more inner electrons, but it's like we go back and we put them in after we filled up another shell. So what I mean by that, let's say that we are dealing with iron. Okay, I'm going to go ahead and circle iron here. This is element 21, 22, 23, 24, 25, 26, sorry. Element 26, the periodic table is a little difficult to read. For right now, I'm just going into the basics. I'm not going into like exceptions and rules, which you'll get into further with AP chemistry, but right now I'm just going into the basics just to talk a little bit more in depth about how Bohr models work. So I'm going to draw my basic Bohr model. I'm going to draw the first shell. I'm going to draw the second shell. So what I can do is I can look, and I actually see that iron is in row 4 because I've got row 1, 2, 3, 4, which means that I'm going to need 4 shells. So I'm going to go ahead. Let's say that I'm trying to get to iron, element number 26. So I'm going to go and begin filling in my Bohr model. So starting with this first shell, I have 1, 2, and what's interesting, sorry, I'm not good at drawing on the computer. If we cross these out, we've got hydrogen, helium, cross them out. And I'm going to keep going, and now lithium, that's 3. I can cross that on the periodic table. And I'm starting to fill up the second shell. So I'm going to fill the second shell up with 8 electrons. Again, sorry, it's hard to draw on the computer with my finger. So I filled those in, 3, 4, let me just go through, use my mouse, 5, 6, 7, and 8. So what's interesting is I already have 10 electrons filled out, and if you look, I've gone up to element 10. So it kind of follows the same order on the periodic table. I'm going to move on to the third shell, which is the third row. I'm going to start filling this in. I have 1, 2, 3, 4, I'm going to go back, double up, 5, 6, 7, 8. And again, that covers the third row, 1, 2, 3, 4, 5, 6, 7, 8. And if you look, I have 18 electrons. Argon is element number 18. I'm doing well so far. Remember that I'm trying to get to iron, Fe. So I'm going to keep going. I start by filling out 1, 2, but now here's the trick. So now here's the thing. I have already filled out potassium and calcium, but when we get to the transition metals are what's called a D block. Again, since we have not learned about electron configuration, this may not make sense, but basically, to sum it all up, there are different orbitals. The elements that are on the left-hand side, the alkaline and the alkaline earth metals, those are what's called the s orbital, and the elements that are on the right side of the transition metals, those are what's called the p block orbitals, and those behave normally we just go through. But when we get into these D block orbitals, the transition metals, they don't want to be valence electrons. They go into the inner circle. So what ends up happening is instead of continuing to fill up the fourth shell, I go back and I fill out the third shell even more. So starting with scandium, I go in and I fill this out and I go 1, 2, 3, 4. So again, I can just kind of keep track. 1, 2, 3, 4. I'm going to fill out 2 more, 5, and 6. And that takes me to iron. So this is what I end up doing. And what we see is that most transition metals have 2 valence electrons because they don't fill out the outer orbital. They fill out the inner shell. But we can't assume that because, like I said, there are exceptions. We're not going to get into that. Now, what I do want to say is we would continue to fill in this third shell all the way down until we got to gallium. And once we get to gallium and germanium and everything past that, in that fourth row, when we're back into those d orbitals, they fill in normally. So those go back to filling out the fourth shell. If this is just a basic outline of how this works, if you would like to know more, you can watch this next video where I'm doing an example of bromine. And if you have any questions, feel free to reach out via email. Bye.